All right, we're back. We are on Calc AB Notes 1, kind of a review of things you already know in calculus, or an introduction to some things that maybe you're a little unfamiliar with, getting familiar with the calculator. Just a lot of stuff going on here. And in calculus, there's a lot you need to know, and we're trying to make sure that you do. So this page, we're going to talk about the derivatives of sine and cosine, which I would say are the most important of the derivatives of the trig functions, but also the derivatives of the rest of the trig functions. So you know what happens at the end of this page? You have a lot more stuff that you have to have memorized, and that's kind of how it's going to keep going. It keeps going, so it's going to snowball. And the idea here is you want to stay ahead of that, right? So it's like chasing you down a hill. It's getting bigger and bigger. Make sure you're understanding everything as you go, and it will never feel particularly intimidating. It's just when you get a little behind, it starts piling up. So make sure everything that you were told to memorize, that you memorize like immediately. Otherwise, it does get scary really fast, and I don't want that for you. So let's see if we can do this. Use your calculator to graph the derivative of f of x equals sine of x. What function appears to be the derivative of sine? Then it says it actually is the derivative of sine. So if you're interested in proving things, I have videos of the proofs of these on like somewhere on the YouTube channel that you can take a look at. I think I just crashed everything. Yeah, I did. Sweet. Oh, maybe I didn't. All right. I don't know. We'll see what happened there when I watch the video, which hopefully is working because I don't want to do it again. All right. So what should I do? I'm going to go to a graph page, and it said graph the derivative. So derivative with respect to x of our function is sine of x. You should definitely use the trig button. I mean, I'm just going to assume that you know that. So use the trig button, press enter. All right, what do we have? We have a function, a trig function, maximum of 1, minimum of -1. Starts at a maximum, intercept, minimum, intercept, maximum. It really seems to me like this is the graph of cosine. It looks like the derivative of sine is cosine. Another thing that we can do, we can just ask the calculator, what's the derivative of sine? It's cosine. Nice. Let's try to go back to the notes and write that in. Hopefully this is all recording. In my experience, once the calculator has screwed up, the videos usually don't go that great, but maybe it'll work. We'll see. All right, so here we go. Now, how can I write that? So I could say if f of x equals sine of x, then f prime of x is cosine. That's one option. And it's fine, but that's like a lot of words. A more common way of writing it is sort of as a formula. d dx of sine of x is equal to cosine of x. This, by the way, is pretty much where dy dx comes from, right? So you're finding, I don't know if this is the time or the place, but obviously it's always the time and the place. You're finding d dx of y, where y equals sine of x, right? And so this notation is super annoying to write. So eventually it just becomes dy dx. You're like, oh, yeah, okay. So like that's one way of interpreting that. There's a lot of ways of interpreting that, which is what probably made that notation win out over other notations. Like Newton, we actually don't use Newton's notation. So this is Leibniz notation, I'm pretty sure. Maybe Lagrange. I think it's Leibniz though. Either way, it's not Newton. Newton's notation for the first derivative was with a little dot over it. That did not win at all. That's gone, right? I think in physics you still use it occasionally. I'm gonna delete it because that's how bad that is. It's not really bad, but whatever. All right, use your calculator. Back to the calculator. Hopefully it's not screwing up my whole video, but who knows? So I'm gonna do the graph thing again, even though obviously we could just, find the derivative, but it's not about that. Like it's about making connections, right? So the derivative with respect to x of cosine of x. All right, look at this. We got a trig function. Looks like the amplitude is 1. It goes starting at 0. It goes intercept, minimum, intercept, maximum. What function is that? That's negative sine. If you can recognize trig functions, your life will be a lot easier. And then let's ask this for the derivative of cosine is negative sine. All right. So it looks like the derivative of sine is cosine. The derivative of cosine is negative sine. So cofunction negative, not cofunction positive, maybe that'll be a thing. I mean, if you follow along, pretty much everything I ever say, maybe that'll be a thing, is a thing. So here we go. Let's write it like a rule. The derivative with respect to x of cosine of x is going to be negative of the sine of x. Okay, so these are a big deal. You know, you'll never want to forget this, and you'll never want to forget this. These are super important. So it turns out that what we can do is we can use those to find the derivatives of everything else. And the way we'll do that is we'll use mostly the quotient rule, to be honest. So if for example, so the derivative with respect to x of secant of x is the derivative with well, what does secant equal? Secant is 1 over cosine. And the derivative of 1 over cosine, I'm going to use quotient rule. So it's bottom. Derivative of the top is 0 minus top, which is 1. Derivative of the bottom, the derivative of cosine we just said is negative sine. Sine. And then all over the bottom squared, cosine squared. Okay, so what does this give me? This gives me positive sine of x over cosine squared of x, which, like, you could stop there, but you're not going to, because that is not the normal way of writing this. And it's really important that you write these in the way that everyone else on earth has decided to memorize them. So what we're going to do is a tiny little trig identity here. We're going to say this is sine. So I'm going to do it in a really weird way. I'm going to say it's 1 over cosine times sine over cosine. And these you'll probably recognize. 1 over cosine is secant. That was like what we started with. That was our basic premise. And then sine over cosine is tangent. So the derivative with respect to x of secant, so this thing, the derivative of secant is secant tan. So sometimes I make a joke that secant and tangent are like secretly dating. And it's because, like, wherever one shows up, the other one tends to show up, including in your Pythagorean identities, where you had 1 plus tan squared is equal to secant squared. It's like, that's suspicious. And then here, the derivative of secant is secant tan. Let's find the derivative. So let's do the derivative of cosecant. I really want to find the derivative of tangent and see if that keeps going. But the derivative of cosecant, and you're going to see, like, it's really similar to the derivative of secant. So it's actually, it occurs to me there's 2 ways I could do this. I could say that cosecant is 1 over secant, and then just go from there. Is that what I want to do? I don't think I do. I mean, that's not the way I've ever done it before, but, like, it seems like a good idea. So, you know, if you do that, let me know. I'm going to change it into 1 over sine and do, like, almost exactly the same process that I did last time. So 1 over sine. I don't know why my handwriting's getting so small here. So it's bottom, derivative of the top, minus top, derivative of the bottom, and all over the bottom squared. Okay, so this is going to give me negative cosine over sine. It's almost the exact reciprocal. Almost. I mean, it's definitely not, because we have, like, a different thing squared, but it's, like, really similar. So I'm gonna do the same sort of thing. Negative 1 over sine, and then times cosine over sine. So this is negative, and then 1 over sine is cosecant, and then cosine over sine is cotan. Okay, do we have a thing developing? I think maybe we do. So this is the derivative of cosecant. So let's take a second and think what we know. The derivative of sine is positive cosine. The derivative of secant is secant tan. The derivative of cosine is negative sine. The derivative of cosecant is negative cosecant cotan. You see like a co thing happening here? So it's almost like the derivative of a cofunction is like the negative, and then it's kind of like cofunctions, right? So like sine is positive cosine. The derivative of sine is positive cosine. The derivative of cosine is negative sine. Like swap cosine for its cofunction. Pick up a negative. Here, secant gave me secant tan. Cosecant gives me negative cosecant cotan. Is that a thing? It's probably a thing. Let's do tangent and cotangent so that we don't stay here all day. So the derivative of tan of x. So same deal. It's going to be the derivative. What is tan of x equal to? Tangent is sine over cosine. Sine over cosine. Okay, so quotient rule. Bottom. Got to remember a lot here. The derivative of sine is cosine. So bottom, derivative of the top. Then minus top, which is sine. Derivative of the bottom, which is negative sine, right? Derivatives of the cos seem to pick up a negative. And then all over the bottom squared. Okay, so what does that numerator equal? You're going to get cosine squared plus sine squared, which should look very familiar to you. So over cosine squared. So what is cosine squared plus sine squared? Cosine squared plus sine squared is, I'm looking for a color that I can use here. This just equals 1, right? That's the Pythagorean identity. So I get 1 over cosine squared, but what's 1 over cosine? 1 over cosine is secant. So this is actually secant squared of x. So did it happen again? Did they show up to the party together again? What are they hiding? Secant squared, the derivative of tangent is secant squared. So there's definitely a secant tan thing. Also tangent, not a cofunction. Its derivative, not negative. There's a lot going on. All right, let's do this last one. Should I do, it's like I kind of want to use, do I want to do that? Bottom derivative? No, I don't want to do that. Okay, so I'm going to do derivative. If I had to guess the derivative of cotangent right now, like say I'm you and I don't know any of this stuff, and I'm trying to guess the derivative of cotangent, I'm going to guess negative because of the cotangent, negative, and then I'm going to take the cofunction of the derivatives of tangent, so negative cosecant squared. That's my guess. Let's find out. dx of, this is cosine over sine. So one thing to be aware of, which I guess you are, hopefully, the derivative of like sine over cosine and cosine over sine they're not just reciprocals of each other in general. That is not a general rule that they would be derivatives, but they would be reciprocals of each other. So, and I mean, just think about it. Like, it doesn't really make any sense that they would be, because like bottom derivative top minus top derivative bottom, all over bottom squared, like it doesn't make sense that that would always work out. But let's keep going. So bottom derivative of the top is negative sine. So I should probably put that in parentheses, but I didn't, and I'm not going to go back. Minus top derivative of the bottom is positive cosine. And then all over the bottom squared. Okay, so what does this clean up to? Well, you can take out a negative, and then you again get sine squared plus cosine squared. I feel like I'm having trouble getting the size of this right today. And I apologize for that, because if you're watching this to learn, I should make it so that you can learn from it. So this, we're going to run into again. This thing is again, or still, it's always equal to 1. What's 1 over sine? So 1 over sine is cosecant, so negative cosecant squared. And I need like another color that I didn't use yet, which, like, I don't know. Well, I know I didn't use this color yet, because I usually reserve that for like final answers on things. I don't know why. I just started doing it one day. I was like, yeah, that's my thing now. All right, so look at that. We got some co-things happening here. We got some co-function things happening. A lot going on. So I'm gonna summarize them in this table. and then you're definitely going to memorize them. So the derivative of sine is cosine. The derivative of cosine is negative sine. So these aren't as hard to memorize as you might think. The derivative of secant is secant tan. The derivative of cosecant is negative, and then just cofunctions, cosecant, cotan. The derivative of tangent is secant squared, and the derivative of cotangent is negative because of the cofunction, and then cofunction, cosecant. And there you go. That's 6 more things for you to memorize, but you could derive them if you needed to. You need to memorize them. I mean, they come up so often that you just do not want to drop that time on it. But anyway, this is a good solid page of information. So I hope you're finding this helpful, and I will be back in the next video to do even more. So see you there.